Hi there, welcome. So today I'm going to talk to us about GIS data format. And this might sound like a simple uh, topic, but I think that it's important for us to look at things from the very foundation. So we're going to talk about some few what data formats are, some examples of GIS data format, and what take-home message we need to carry when we look at GIS data format. So let's start with the definition of a file format. In in computing, I've already explained in my previous lectures where there are a lot of standardizations because we need to ensure that resources can be moved from one place to other and they maintain their integrity. So a file format is a standard way that informations are actually encoded for storage in the computer. And it has a set of conventions for storing them. I'm sure you are very familiar with many file formats you've been using a lot of them. Some of them are what you see on the screen. You see GIF, you see PDF, it's a file format. You see TXT, doc with Microsoft Suite. You see Excel, PowerPoint. You get to see some audio file format and stuff. So these are all standardized ways of storing the information so that you can be able to retrieve them and move them from place to place. It stores the information in a standardized protocol. So it's like whoever, no matter the person, when you want to store your data in a particular format, any other person who is familiar with that format can be able to review the data. It's on condition that if the file format is an open source or it's from a vendor. But if it's an open source, he can view most of the data, all the data, and then gets to make changes or probably tune it to his or her preference. However, some file formats are very specific and some of them are general. Some of them can work in a very specific environment because they were designed for those environments, whilst others can work with multiple environments. Start from it's the data standard are also needed basically because we want data to be uh, transportable and portable when you are transporting them. And so if you are moving data from one file to the other, you would be able to use them as easy as you can. An example is when you take a pen drive and you copy your data and you give it to another person, or you copy your data from one computer to another. Because of the file format and the protocols ensured in file formats, you are able to move the data from one computer to the other without uh, too much problems. Most of the time, file formats are mostly ending with a period. So you would see a name of a file and you see dot something after it. It could be anything, but these figures we are seeing, JPG, GIF, PDF, these are all the extensions, what we call the extensions, the file format extensions. And this is what the computer knows. The computer understands these protocols. So once you save a file and you put the name and add .pdf, if you save it automatically, it's going to be PDF because the computer understands that. If you say .xls, the computer understands that. And it's this the dot when you put the file format name to attach it to a file name, it's more it takes more supremacy over defining the file just from the computer. So if you have, let's say, you're saving a file and the file type, many of the dialog that pop up, you have a file type and you have a file name. If the file type says that it's a TXT, it's a text file, but when you were saving it, you added a .pdf, it's going to save it as a PDF even though you see text file in there. So that's how powerful these things are to the computer. Now let's come to GIS file format or GIS data format. We have already discussed about the data types we have in GIS, and we have vector data, we have raster data. And so in GIS data formats or file types, we have vector data formats and we have raster data formats. We have data sets that are or protocols that are fit for storing data within GIS data for raster data set, and we have one that is stored for vector data set. Under the GIS vector data set, you would see some of them, some of the protocols are fit for storing time series data, that is temporal, things that has happened over time. They have a structure that allows you to do that. And then we also have a timestamp. Most of the file format is actually created to store a timestamp. So you have a data that represents a particular time and a particular uh, date. It was collected at a particular time and a particular date, and it's just like a timestamp. But there's also data types that can actually have time series. There is also under the raster, we also have 3D file format. So file format that allows you to store in three-dimensional space or to store data that can be used in a three-dimensional space. And this, we are going to talk more about the vector data format in this lecture, but just feel free to explore. And the idea is to be able to introduce you to this whole idea of file format and the many of them that you see flying around, but probably you have not taken a look at. There are so many file formats that I cannot list all of them. Some of them are what I have listed here, but the ones that are in red are the ones that I'd want to talk about. So shapefiles, geodatabase, geopackage, geojson, KML, spatialite, NetCDF. These are the common ones you are likely to see. However, you are going to see a lot of them depending on what you're doing. But these are common ones that we will go through, and then we would try to use this. By the time we talk about these ones, you would have gotten the point. So there's no need to go through all the file formats that are there. But there are tens of file formats that are there. The first thing we will talk about is shapefile. Shapefile is originally created by Esri, and it was very compatible with the Esri suite. So the Esri desktop suite, the Esri ArcMap and ArcGIS Pro pretty well understand shapefiles. Now the structure of the shapefile is designed to separate different informations into different documents, which is a file type, and each of them has a file extension, and it has what we call the mandatory files and the optional files. The mandatory files has to be shared together. If you have the DBF, if you have a shapefile, you see that it will have .dbf and it will have .shp and it will have the .shs. The DBF is the database that is storing the attribute information within the data. SHP is the one that stores the geometry, whether it's a point, line, or polygon. And then SHX is the file that stores the index of the geometry. Now, if you have if you have to share data, you have to share this shapefile, and you just share the SHP. When the SHP is loading, it will try to communicate with the DBF and then the SHX, and it will not find it. Once it doesn't find it, you will get an error. So you have to share this data together almost every time. However, there are optional files, and these files are actually optional because the shapefile would work without them. If you create a new shapefile, you might see this major three, but then when you perform certain operations on the data, it produces and it creates extra files. So for instance, .sbn and then sbh are four file formats that stores the spatial index of features. And this only happens when you perform certain processes like selection, spatial join, or you create an index. These ones are created automatically because it fast track the processing of the data. If your data is big, if you have a special index on the data, it helps you to be able to uh, reduce the computational time. So SGIS, most of the time, SGIS environment would automatically try to create this index for you for some of the geoprocessing that you would do. And these two files would be added to it. So if you get a file and these ones are not there, do not panic. Probably they have not performed any processes that requires that special index be created. If you have a file and you have not projected it, you will not see the .pgr, and most of the geographic coordinate system which is not yet projected might not have any .pgr file. So that's why these ones are mandatory, because these ones are added through pre-processing, or these ones are added through geoprocessing. Okay, so that is the structure of the shapefile that we have. Most of the time you see the extension as .shp. When you are loading the data, you will use the .shp because that's what contains the geometry. But when you are sharing the file, you don't need just the .shp. You need these three mandatory ones. If you have these ones, you can add them to it so that whoever is looking at the data would be able to understand the projections and the coordinate systems in there. But if not, you have just these ones, then these mandatory ones would be of good. Geopackage. Geopackage is actually open source, unlike Esri's shapefile we've talked about, which has multiple files within file kind of structure. Geopackage is an open source, it's standard based, and it's a platform independent. It can work with multiple uh, environments. And Geopackage, it's actually that, like the name is, it packages all your files together as one. So your point, your line, and polygon can all be packaged together as one file. So it's portable and you can actually move it easily as you like. Geopackage, to my surprise, I learned that Geopackage is also very useful for mobile devices and cell phones or tablet communication, especially in areas or in environments where there is limited connectivity and bandwidth. Okay, so Geopackage is actually more like inheriting its structure from a database structure, which is the SQLite container. So because of that, it supports direct use. You can use it directly, and it's interoperable. You can move it. It works in different environments or different computing environments, whether it is open source software or it is commercial software. It works in them. You would most of the time see .gpkg as the extension. If you are saving most of the time in QGIS or ArcGIS, you would this thing is likely easy to do. But if you are, let's say, writing a script and you want to save your file as a GeoPackage, you need to provide a file extension of the .gpkg to be able to get it in a GeoPackage format. The next thing we want to talk about is the keyhole markup language, which is KML or KMZ. The KML is a file type. KMZ is a zip format of the KML. Now, this is a very common file structure for Google Earth Pro platform. Now, the KML is actually an XML base. We have not talked about XML and we will not talk about XML, unfortunately, but it's an XML based language focus. That it's a language that focuses on geographic visualization, and it includes annotation of map and images. Um, it's it includes just not the graphical part of it, but also it has the ability to control the user's navigation in a sense that you can tell where to go and where to look out for. It's very now common in most of the existing standard that we have, which is like example is the web feature service and then the web map service, which are basically used. These are file types that are used on the web, and Geopackage, KML is very important, or is playing key role in that. When you save any data from Google Earth Pro or Google Earth platform, you will get the data in a format .kmz or .kml. It depends. If you have multiple files save as one, then you get .kmz because it would zip it into one. If it's just one file you are sending, you might get .kml. So that is also another type of file format. And most of the time you would have to convert it because it's not, from my experience, it's not a file format that you get to work with it from beginning to the end of your analysis. You would basically bring it and try to convert it to the other types of data file formats you have so that you can be able to work with them. NetCDF. NetCDF is actually a set of software libraries, and it's independent. It's more like a machine independent data format. And the advantage of NetCDF is that it allows to create, access, and share array-oriented scientific data. When I say array-oriented scientific data, if you look at the images here, if each of this cell or each of this grid would have a value, and these are actually an array. But the interesting part is that it has a third dimension, which the third dimension is actually the time. So it allows you to represent data in the form of space and time, which means you can have a temporal data, a data that is not a timestamp just alone, but it's a data that actually gives you information about an object or a phenomenon over a period of time. Okay, and it is the model and the encodings are particularly suited for atmospheric data that is in a form of familiar structure like the atmospheric and oceanic uh, data. And basically it's array. And so when you want to represent your data you want to add a temporal component to your data, then you have to start looking at NetCDF, because if you use the other ones, they are timestamp and you would not have the option to keep the the temporal like you would do with NetCDF. GeoJSON. GeoJSON is quite common nowadays. It's very popular now. I think it's because of its flexibility and its uh, open source, and the fact that you can actually be able to uh, view GeoJSON. You can construct GeoJSON, and it's just it's an encoding collection of simple graphical features, which is based on JSON language. And so you can, it's just a collection of like a dictionary, a value, a name value pair, and it is not really strict. And so you have it doesn't give you schema, it doesn't impose a schema on you, it doesn't really uh, give you a rigid structure how you should organize stuff. But once you have the key value and pair, you can actually call the value using the name that you assign to it. Okay, and it's very human readable. If you look at this, we can actually read this is the type, it's a feature collection, and the features are actually a geometry, which is a point, a type of a point. This is the coordinate. It's human readable and you can easily read a GeoJSON. So GeoJSON is also a common format that we use. I think the last thing I will talk about is geodatabase. The most important thing you need to think of about geodatabases are they are files mostly in a folder and they are on disk. So they are stored, they are created to sit on disk, to store, to query, and then to manage spatial data and non-spatial data. This is a database, and this is an example of what I said in our first few slides, where when I mentioned that some of the data sets are platform specific. So if you are using um, Esri's desktop application, you are likely to be using either file geodatabase or personal geodatabase. If you are using PostGIS or PostgreSQL's database, you are likely to be using uh, not necessarily file geodatabase or personal geodatabase. If you are using um, QGIS and you want to use SQLite, you are likely to use a data structure that has a form of SQL. So these are more platform oriented and you would be restricted. These have defined schemas. And when I say schema, it's more like a structure that tells you what data type needs to be put where and how data should be organized in a table or in a framework to allow the computer to be able to read it. And so this is also another form of file format you have to deal with a lot when you start doing GIS. In conclusion, what this whole lecture is trying to help us to understand is that every data that we process would be structured in a file format. So we just need to understand the file format. Some of the file formats actually cast restrictions such as schema on the access and retrieval of the data that is embedded in the file itself. And then some are also more flexible. They are general. They are open source. You can actually, it's readable. You can easily make changes and stuff to them. Some of them have a temporal aspect to which allows you to look at things over time. So if you are interested in a time series, then you have to look at data file format that actually helps you to capture that kind of information. Some of the file formats even have the ability to uh, if you know the file format you need to use for your project, it either promotes your project or it can limit your project, because if you understand that you need a temporal base or a file format that has information about time series or temporal information, then probably you'll be looking at NetCDF. However, NetCDF is also, you also look at the kind of data you are capturing, whether NetCDF is structure or protocol is good enough for it. But knowing your file format required for your project will do you a lot of good, because each of them have their own advantages and disadvantages. I just introduce you to them just for you to understand that they are very important, and you would have to convert your data into one file format at some point. You might get them from multiple sources, they might come in different formats, but you may have to put all of them in one format at some point. And that's when this lecture or this small discussion will become handy, because which file format do you put them into? What is your goal? What is the future use of the data? Are you going to put them in a database? Are you going to put them you're going to use them in an Esri platform? Do you ever imagine that they would move out of the Esri platform to another platform that is not Esri really based? If those are the situations, do you want to consider a general independent file structure that is interoperable, or you want to look at a file structure that is a platform independent, like the other ones we have discussed? If these ones are your decisions, then you can make good decisions about them. It is important to make these decisions, because when we're talking about data quality, one of the sources of errors we mentioned was the transformations. The more you transform data from one file format to the another, there's always some sort of RMS error, root mean square error that you encounter. And the more you do, the more your deviation margin. And so it's important to reduce the trans number of transformations that would be done on the data, and make a decision to put the data in a good format once and for all, so that you can avoid and reduce these errors. I know that when you start using them, probably you've used some of them before, and so you would be able to appreciate some of the things that I'm saying at the moment. But I hope that you would have a good class during the one-on-one section with our instructors. I hope that you would get the opportunity to think about and read more about these file formats and even others that we have not presented, so that you can be able to make good decisions and know your stuff, know the right file format for the right job. And if we do this, I think it would make our life easier. Until then, I'll see you again in the next lecture. Bye for now.